name is Stephen Gottlieb, and I made up the probability theory video. At this point, I would just love for you to sit back and view a sample demonstration which I made up. I'm going to go over a classic problem. It's called the Monty Hall problem. For those of you who remember, Monty Hall used to be the host of a TV show entitled Let's Make a Deal. And the following situation came up regularly. There would be 3 curtains. Curtain number 1, number 2, and number 3. One of which had a nice price, a brand new car. The other 2 were empty. And Monty Hall would pick a contestant from the studio audience and ask them to pick a curtain. For argument's sake, let's suppose they picked curtain number 1. Now Monty Hall knew which curtain had the grand prize behind. Let's suppose it was this one. What Monty Hall would then do is say, okay, so he would then show you a losing curtain that isn't yours. That is, he show you number 2. Because this is a winner, a loser, and a loser. He would show you curtain number 2. And then he would ask you, do you want to switch? Of course, if you said yes, you wouldn't switch to number 2. You would switch to number 3. Another scenario would be is you pick curtain number 1. And curtain number 1's the winner. So Monty Hall would show you a curtain that isn't yours, that's a loser. He will show you one of these 2. Say he showed you number 3. Then he would ask you, do you want to switch? Do you want to switch from curtain 1? Of course you would go to curtain 2, and in this case you would lose. So the question is, should you switch? Should you switch? Now, there are 3 cases. The winning curtain is number 1, which means 2 and 3 loses. Or the winning curtain is number 2, which means 1 and 3 are loses. Or the winning curtain is number 3, making curtain 1 a loser, curtain number 2 being a losing curtain, and curtain number 3 being the winner. Now, let's look at what happens if you don't switch. You don't switch, or you switch. Let's see if you win or you lose. Now, without loss of generality, and you have to think why this is true. It doesn't matter if I say you always pick door number 1. The bottom line is, no matter which door you pick, 1 out of 3 times you will have picked the right one. And that's my setup here. If you pick door number 1, only 1 out of 3 times will you win. It doesn't matter if the first time you pick 1 and the next time you pick 3, the next time you pick 1 again. You have a 1 in 3 chance of winning. So we can just say, for argument's sake, let's suppose you always pick door number 1. Okay. Now let's look at this case. If you pick door number 1, Monty Hall is going to show you a losing curtain that isn't yours. That is, okay, if you don't switch, you won, you lost, and you lost. You won, You lost and you lost. The probability of winning, given that you don't switch, is 1 out of 3. You win one time out of 3 possibilities. What is the probability that you win, given that you do switch? Well, let's see. Let's do the last one first. If you pick door number 1, which is a loser, Monty is going to show you one of these doors, but it's always a losing door. So he's going to show you 2. And of course, if you switch, you're going to go to 3. You're not going to pick 2. They showed you it's empty. Behind the curtain, it's empty. So if you pick 1, if you're going to switch, you're going to pick 3, and you're going to win. Okay? Let's go to this case. If you switch, so if you pick door number 1, between the 2 remaining ones, only this one's a loser. That's the winner. Monty Hall will show you what's behind curtain number 3. And I'll show you that there's nothing there. See, if you switch, you're going to go to 2. And you're going to win. Now, if you win, if door number 1's the winner, Monty Hall is going to show you a losing curtain that isn't yours. Now, no matter which he shows you, if he shows you 2, if you switch, you're going to switch to 3 and lose. If he showed you 3, if you switch, you're going to go to 2 and you're going to lose. No matter what, if you switch from 1 to winning curtain, you're going to lose. So, out of the 3 cases, out of 3, you won 2. So, the probability that you win if you switch is 2/3. Probability that if you win, if you keep your original curtain, that if you don't switch, is 1/3. 2/3 is double, it's twice 1/3. You have 2 times as much of a chance of winning if you switch than if you don't switch. So the real question is, I don't know if I stated it correctly, is should you switch? In this Let's Make a Deal curtain game, should you switch? The answer is yes. Go with the odds. You double your chances of winning if you switch. This completes my sample demonstration. Hope you learned a little bit about the Monty Hall problem. Hope you understood a lot about the Monty Hall problem. And you can now amaze your friends who are going to say that it's going to be 1/3. They're all going to say it's 1/3 if you switch, but it's really 2/3. Most of all, I would like to wish you great success in your probability theory class. And thank you very much for viewing my video to the very end.